Hello, hello, this is Grace. This is the second dev session video. So we're going to pick up where we left off last time. And last time we talked a little bit about how we can model data in our applications using MobX, and hopefully I guess I also brought in a little note about Webpack modules. I'm not going to worry about that today. That could be something down the road that we look at. But I guess one of the things that one of my goals right now is to try and build out a proof of concept apps. Just kind of apps that we can put online, confidently point people to and say, here, try these out. And this gives you an idea of what we can build. So we have two apps built already. One is called Slim. It's a lab management application. Basically, this simulates, or this app would be used in a chemical lab where chemists need to test materials to make sure they meet specifications. So this text field works with a barcode scanner. I don't have a barcode scanner on me right now, but so I'm just going to simulate it by dragging this in here. We get different samples in here. There's not really sample data in here right now, but like this app works for us to click around. It wasn't too difficult to build, although there's some things about it that I'd still like to change. The other app that we have as a demo is a point of sale system, and don't judge, but it's not the prettiest thing in the world. So this is a system that we built out for my friend Matt's karaoke and pool and mahjong establishment at Michigan State University. It's called Nimbus. Essentially, these everything in the business you can book out on an hourly basis. So if someone wants mahjong table number 4, you can click on it. It starts kind of tracking the time and the amount that the group owes, and then they can add snacks or drinks to their tab, and then check out. So let's say $11. Cool. So that's essentially the app. I've started to build out reservations. It's not working right now. And there is also an admin dashboard. Oh, there should be. I'm not sure why that's not working. Okay. Yeah, forget about the admin dashboard for now. So this app is a bit broken, I think, as you can see. One of the things that I'm not quite sure, we just clicked on KTV room number 3. If we try to navigate away, the navigation is broken for some reason. I think that's it. Time seems to work okay. There were other... Seems like other things are working all right, and the reservations are not implemented yet. So this app generally works, which is frustrating because the code for this app is so messy. And I just looked at it for the first time in a while, and it is a struggle for me to even tell what's going on with it. So So I'm debating, and I don't know if this is a good thing for me to do or not, but I'm debating taking a step back from this app and trying to, at least for a little bit, start from scratch. Let me explain why I'm thinking that. So, the app generally works. It's a React front end that calls out to a server on the back end to pull all of its data into whatever. I guess just store the data on the back end. It doesn't talk to any other systems. It's basically like what you see here is what you get. There is like a legacy component to this because this app was initially created as a Rails application, Ruby on Rails, and we still have kind of some Rails code on the backend server that powers it, but for the most part, all the front end code has been pulled out into a separate React single page app. So we want to get this React single page app that is the front end. We want it to not depend on a Rails backend, I guess we can say. Huh. All right. I think I think we have maybe an opportunity here where like the data that powers this app is complicated. Let's take a look at it. So I'm gonna just refresh the page here and we'll look at one of the first requests that it gets. This is a bunch of JSON that the app goes out and fetches from the server that represents the state of the application. And everything you see in the app is based off of this JSON request. So we see there are services, and it's just a list. The current, so Mahjong 1, the first Mahjong room, has an hourly rate of $20. There is a current order associated with it, which means that a group is at the table, and the start time was 5:26 p.m. The cash amount is dynamically calculated on the front end, which seems to be better until the group closes out. It seems to work better if we just track the start time and then wait until later to calculate the dynamically keep track of the amount that's owed just as a calculated value and only persist that once the group closes out. So I guess the problem with this is that all of these services are just plain JSON values. Down here we have, like, if we click in on this, all of the drinks are just listed as extras. So playing cards, bottled water, lemon, Diet Coke. They're all, I mean, once again, just JSON objects. And yeah, I think that's it. So so the problem with this is, like, let's say we want well, perfect example here is that in this checkout tab, right, we're on Mahjong 1, the checkout. So we want to display this $46 in 2 places in the app. $46, $46. The way we're doing it right now, we are, I guess we have 2 completely different places where we're calculating that $46. And in both of those places, we're just kind of looking at this JSON data object that we have and applying calculations to it. It would be much nicer if we could use some object-oriented principles. If we could kind of, in abstract terms, if we could describe how to calculate the total cost of an order in a way that, I guess, let me start over a little bit. It would be nice if the system, if we could tell the system that there is a concept of an order, and an order has a start time, end time, a certain amount of extra charges on the tab, etc. And when the system kind of recognizes this order concept, and then once we have that order concept in the system, we can start attaching behaviors to it, like calculate the amount owed, things like that. So that's kind of a 2-minute explanation of object-oriented programming. There's so much literature on the topic that I won't dive into it now, but I think it's an important thing to get right in this situation. And it's important to get right because I think I mentioned in the previous video that one of the most difficult problems that I've been hitting a wall with is, how do we attach the data of a system to the user interface? And it very well may be the case that object-oriented programming has a good answer there. We don't seem to be getting very far by representing our data as just JSON. That's what we've been doing so far, and it's, I mean, one, I'm the only programmer working on these apps right now, and it's difficult for me, even the person who wrote the code, to keep track of where all of the data is stored. Because if you build out a very specifically structured JSON data store, then you need to remember that structure in order to get at the data you need. It's not ideal, especially if we introduce more developers to these apps, then it's not sustainable in any kind of way. So that's kind of the overall picture. It's, I guess what I'd love to see on this app, and this might be a good scope for this video, is I'd love to see a description of what an order looks like in the system, a description of what an extra looks like in the system, and maybe a description of, mean, those are two good starting points. Reservation maybe, but that's not implemented yet, so that might actually be a better starting point. I don't know. Okay, so this will take a little finagling to figure out what it should look like. But once we have that, once we know what an order looks like, then first of all, we can create that, like all of these, all of this UI right here, which right now is kind of calculated that the UI should look like this because there are, just because there's logic that looks at the JSON structure. All of this UI we can start to much more closely tie to the object-oriented description of the data. So this kind of section right here, I'll just do, okay, hold on. Like one of these sections, we can kind of build this out as a reusable, I mean, it's already a reusable component, but we can kind of tell the system that this is one way to display an order. And kind of this over here is another way to display an order. And so I think if we take that approach, then we get much more reusable components that are, or much more reusable interfaces that are kind of directly tied to data instead of kind of very loosely tied to data. I guess I would say that the relationship between the UI and the data is much more explicit, where each of the components on the page knows exactly what type of data that it needs in order to display and behave correctly on the page. So kind of if we try to put one of these elements on the page without an order behind it, then the page element might be able to kind of warn us this isn't going to work because there isn't the required data behind it. All right, that's the gist. Let me pause for a moment and take a breather. All right, what I just did was I made a couple changes to the app to just make it display better in split screen, and I basically found a good starting point for our changes. So first place we're going to look at is our app component and component did mount. This is, I guess, the first thing that the app will do when we load it up. If we start it here, if we refresh the page very briefly, you will see a loading ... text up in the top left. Oh, here we go. Yep, and then it loads. And so when you see the loading text, that is essentially we display that while this component did mount function is running. So the thing that this component did mount function, we essentially tell it to run a command on our backend server to fetch all of the services that are available and to fetch all of the extras that are available. Now, looking at this is fine code. It's not, I mean, not super problematic, but since we are building out different, I guess since we're modeling the services and the extras in our app separately, we want one class for all of the services and one class for all of the extras, then it seems like it makes sense as a good starting point to break this call up into two different ones. So that's what I'm going to do here. Okay. I think this captures it. Oh. Alright, so here's a slight problem where we have our app. Okay. Maybe this wasn't such a good idea. And the reason for that is that we're kind of, hold on, there we go. Just the way that I set up this logic originally is not great. Basically, we have this variable called loaded that indicates whether the app's data has been loaded or not. Okay. Give me a second. And and so what kind of, this didn't seem like an issue at the time, but what it means right now is that we're kind of constrained to just a single request. So if we want to wait, if we break this up into two requests, we'll have to make sure that the app waits for both of the requests to finish. And that's kind of an annoying situation. But maybe it's not much of an issue. So let's see. App state will kind of fall out into two different variables, services and extras. And we can do app state dot services. App state dot extras. And yeah, so this should give us the exact same thing that we had before, just kind of we're being more verbose about it, a little bit more explicit. And one of the nice things that we can do here is we can call it map with a parse service and map with parse extra. Alright, those functions will not exist, so we get not defined errors. Let's go just anywhere in here. Not there. Say parse service takes a JSON object and returns some, I guess not a JSON object, but a more fully fledged object-oriented object. And we'll do the same thing with parse extra. And so for now we can, if we just return the JSON, then it will behave in the exact same way, hopefully, as it already does. Cool. That's great news. Sounds good. So now we have to actually describe the data. And let me pull up. Oh. Let me pull up that data page again, and maybe we can capture what the data looks like. All right, so let's focus on services first. Let's see if that copy paste gives us anything. It's weirdly formatted. Can we? All right. Just go straight to the JSON. All right. Oh well. Here, let's do this. Okay, so this is kind of what a the order object looks like, or sorry, we're actually talking about the service object. That doesn't parse. Let's go to source. I guess we'll make a folder called data, and we'll call this a service. Okay, so there we are. Let's, I guess, here's kind of where my knowledge ends. We'll do, I'm just gonna make this up. I think it'll be kind of straightforward, but actually, I know it will not be straightforward. So we're going to want to pretty quickly all right, let me not get ahead of myself. So let's just take all of these items and I guess by default they're null. And then a constructor takes in those values. I mean, this seems like a really not great way to do it. Very verbose, but it'll probably work, so I'm doing it. This is overkill for macro, but I'm doing a macro. Special recursive macro. Okay, cool. We're good. So we got our constructor. So now we'll be able to equals new service, and then we'll pass in something like hourly rate 20, name mahjong. If we pass in all of those things, then we'll have that service object. All right. That seems straightforward enough. And we can test this out by saying return new service. Come on. With. Okay. So our JSON, I mean, I think we're just going to pass the JSON in here. Okay, service is not defined. Import service from data service. Cool, so we didn't get any errors, which is great. We also do not have the items coming through in here, which is probably because we did not make a place for our current order variable. So let's do that. So far, this is behaving purely as a, I mean, we're writing all of this boilerplate to essentially make this a plain JavaScript object, which like so far we're just spelling out a lot of code that the system was doing on its own before. So there isn't really, we haven't added value to this yet. I guess one of the places that we can start to add value is looking back at this function to calculate the total cost. So let's say that the current order is a new order, and that will parse the order values. So I mean, this is going down the rabbit hole, and this is necessary boilerplate, but all right, so our order will now have these values. come on. And here we'll do cool. So this will behave exactly the same as the service, which, I mean, in turn will behave exactly the same as the plain JSON object. So we haven't changed the behavior of the system here. Let me just document this a little bit. Cool. And export default order. We need to import order here. Should still work all the same. Nope. Where is values? Okay. So right here we tried to make a new order where the current order was null. So I'm not sure the best way to do this, but for now we can do just check to make sure that that order exists before we parse it. All right, sweet. We have our app working. It's there. Cool. So the logic for calculating this 4033 and this 4033 still live in two different places. Now that we have this order object, we can combine it into a single place. So let's take a look at what that would be. So I guess so here's one of the places. Oh. Okay. Check out. Where did we want? We wanted data order. All right. So here's our order class that we just created. In the top here, the top file, we are. This is the first place that we calculate the bill amount, which this is actually the checkout. So that's displaying the amount here. And this bottom pane is the table, which is the name for this component, 4033 right there. So if we look at where we use the bill amount function, we've got two different places. So in both places, we are taking the order prop and passing it into the bill amount, there and there. So easy enough, I guess. We create a function here called bill amount. And we go track down that function. And we move it here. With all of its friends. is a lot going on here, but it should get cleaned up soon. So we can remove this file. The bill amount we do not need anymore. Okay, in there. And instead of calling bill amount and passing in the current order, we will take the current order and call the bill amount function. Unfortunately, I mean, we can fix this up later, but we still need to pass in a couple values, which are the hourly rate and the current time. So let's accept those here. And let's do the same thing down here. So we have our order bill amount with the hourly rate and the current time. Let's see what happens. So we're getting a complaint about time component, and since we've moved this into a class, we need to change it to this dot time component. Maybe. Oh, just in one of those places. Extra component, okay. Let's do some of that stuff down here. Alright, order is not defined, rate is not defined. Where's order? Okay, so this is kind of a common thing that we'll see when we do this refactoring, is that this function took in an external order object, and since we just moved it into a class of its own, we can just delete all the references to the order. So for example, it was possible to call the bill amount function without any order. Now that's no longer possible, because if an order doesn't exist, you can never get to the bill amount function. The bill amount always kind of is tied to an order now. So the time component, you can get rid of that function. Extras component. This order here, it used to be an argument, now it's just the current object. Cool. Rate. Okay, oh, just misnamed the variable. And awesome. So it works. That's very cool. That was pretty easy. Now, I guess that's a success. If we look at what we did, I mean, this is kind of a mixed bag because we introduced a lot of boilerplate here. We have these functions that are just hanging out. They don't really do much, but they're necessary now. Bill amount. Okay, we got rid of this bill amount file, which is great. That was kind of just logic that wasn't attached to anything in the system, and now it has a home. It's great to see. So okay, so let's see. This still could use some cleaning up, because I think that an order should know which service it's attached to. For example, you can't have a person who comes in and just says, I want it. I mean, you would only be tracking the hourly rate if someone has booked a room or a table or something. Now this does make things a little complicated because there's always the case of what if someone comes in, just wants a drink without booking a pool room or karaoke room, whatever. But I'm not going to worry about that right now. Alright, the other thing, so we just got rid of this file. Okay, so this is like a very small win. Super small win. We ended up adding a lot of code. Like more code than we removed. Like 3 times as much code as we removed. So I'm sure there are benefits to this, but they aren't here yet. We haven't gotten to the benefits yet. So, I mean, I suppose we might see a benefit here. Like, let's look at, let's try to find this table object, right? So this table, in the interface is an instance of this table component that we were just editing. So previously, the current order, like the order that the table displayed and the service that the table displayed, were just JSON objects. Now we can see this. The current order is an order object, which is great. Yay. Everything else is passed in directly. Okay. I mean, it's a small win, but this, I think, I don't know why it's flickering. Oh, it's flickering because it's recalculating the total every second. But so just this, being able to see that the current order is an order object instead of a loose collection of JSON data. Just putting the name order to that collection of data, I think helps us out a lot and will make things a lot easier down the road. And I'm not quite sure what the fallout of it is, but I mean, it seems like a low effort task to do up front that will probably give us a lot to build off of later. So I'm going to do that for the rest of the app, and then we can take a look at how MobX might come into play here. All right, I'm bringing you back for a brief moment before we upload the video. I had actually started to upload this and then kept going with the refactoring and pretty quickly noticed something that I want to call out. So let's look back in the app to a table with an existing order. All right, so this table, which is pool 3, it has that current order object. I guess it has a current time object, which is necessary for calculating the value. And that seems like a weird thing to need to pass in there, but who knows? Okay. History also seems like a weird thing. Wow. Okay, we're passing a lot of data into this table, and that's not a horrible thing to do, but it makes it difficult to understand what's going on when you just look at this component. And if we look at this, the table, just for context, the word table and the word service are kind of interchangeable. Just a quirk of how we named the objects when we built the app the first time. So if you see the word table over here, that's describing this UI element, and you see the word service. That's the name of the data that we just created. So we should probably make those the same, rename one of them, but that's not the issue at hand. So the issue at hand is that we have a few items of data. We have the service, we have the position, the name, service, position, name, and hourly rate. All of these data points we're just kind of passing into the table element without taking advantage of the fact that they're all logically grouped. So we can change this around to take advantage of the fact. Right here we're passing in this table object. That those three dots are kind of a spread operator, which means take all of the data points in this table object and just pass them in independently of one another as separate variables. So let's get rid of the spread and let's call this table data. I don't know if data is the right word for it, but it's a generic term. We can actually get rid of service as well, I think. Okay, so now instead of passing in those objects separately, if we broke the table, but if we look at it now, table, the data object is a service. So, and we look into that service and we see the order, we see the hourly rate, the pool, the name, position, service. Cool. So all that's left, we don't actually need to handle anything in here. We just need to fix the table object. So that will be in source components table. Nope, table. All right, and in here, so we're looking for hourly rate, and basically now this is subset under data. We're looking for name, which we don't use in there. We're looking for a position, which we do use. Data.position. Cool. Looking for service. Data.service. Oh. All right. And we're looking for current order. And we should now have access to all of that. So that's great. Cool. And now just to prove the point, I guess, we look at this table now. There's less data passed into this. The kind of if we name like the data that each component requires, if we call it data, then that's kind of a common way for us to keep track of the data that a component needs in order to render correctly. So that's great. Let's see, current time, data, history, location, match. Okay. So these three all come from routing. This is an event that we might be able to get rid of later with mobx. Static context, I have no idea where that's coming from. That might be a router thing as well. If we leave out routing and this action that we might be able to get rid of, I mean, current time I think we can also get rid of, but that's a trickier one. But yeah, I think like we can essentially get away with a single data property that we pass into each component that the component can look for. The component can make sure it's receiving the right data before it displays itself. The component can take advantage of any methods or functions defined on the data passed into it, so we can take advantage of object-oriented patterns here. Seems like a better approach. And I'd like to start knocking off the rest of these props that we pass in here. And I mean, and just, I think be able to, like, we're getting a good start. I think if, like, we have a map here of all of the elements in our app, it would be really nice if these elements in our app all boiled down to, like, what is the data that it's displaying. If we could click on this lobby and just see, like, what's the data? The data in this case would be a list of services. So maybe we change this name to data. And besides that, I mean, the only real thing to tackle now is how do we kind of take this data and persist it on a server somewhere. So this doesn't get us much closer to like, if I make a change to this to any of these data, right now there's still custom code that has to run in order for it to get saved to a database, and I don't think that the code needs to be custom. I think we can get a one-size-fits-all solution for this. I would like to see, let's see, come here. Okay, what's going on? Let me just delete that. Okay, I would like to see a way that, like, we don't have to define this this class automatically. So if we can just specify kind of what a service looks like in a really easy way, kind of even a drag and drop way, or a spreadsheet way, then I think we're on the right track to developing apps with zero code, which is the end goal. So I think this has been productive. It at least is giving me a bit of a clear picture of how we might tie in data to the app. So I'm gonna keep going until I hit another roadblock, and then we can talk about what the way around that one is. So I'll see you next time.